All right, students, let's finish things off. Problem number 5. So we kind of got done with a pretty tricky problem. Well, not really tricky, it just took a lot of time. Let's finish things off with a very, very simple problem. Graphing these. How can you graph these in a matter of seconds? Very, very simple. These two numbers, excuse the bell, these two numbers tell a story, okay? Remember, this number tells you where to start, and this one tells you how to step, where to begin, how to move, whatever analogy you want. So I'm gonna start at a -1, I'm gonna move by 2. What do you mean move by 2? 1 to the right, change in the height, or rise over run. They do the same thing right here. The y-intercept is -1, so start at 0 and -1. Okay, boom, they start right there. Now they do rise over run, okay? But again, if the slope is a whole number, I like to think 1 to the right, change in the height. Same thing. You have 2 points, play connect the dots. It takes seconds. Remember, use the 2 clues. Where do I start? How do I move? Where do I start? How do I move? Where do I start? How do I step? All right, here we go, moving on. So, what is the graph of each of these linear equations? So I have myself a blank little graph ready to go here. So here's 5a. So I have a y equals a -3x plus 4. Here's where I'm gonna start, and here's how I'm gonna step. Excuse my pen, there we go. So I'm gonna go 1 to the right, change in the height, and I'm gonna start at a +4. So again, that's the y-intercept. So here's y, here's x, I'm gonna start at a +4. 1, 2, 3, 4, I'm gonna start right there. There we go. It's a y-intercept of 4. Now I have a slope of -3, I'm gonna go 1 to the right, change in the height. So I'm gonna go over 1, down 3, there's my next corner point. I can make another one just for accuracy, same step, same step. There we go. Once I have enough steps, I can now play connect the dots. So let's do that right now. Here we go. Nice and accurate lag. Make sure I hit all the spots. Boom. There we go. Takes more time drawing the line than it does to figure out where it goes. So again, look at the connections here. So there's my y-intercept of 4, and then 1 to the right, down 3. 1 to the right, down 3. These two numbers tell you the story. Okay, moving on to the next one. We have y equals a 4x minus 8. So I'm not even going to mess around. I'm just going to get right into, oh, do I have enough for -8? I hope I do. If not, I might have to mess with my graph. 1, 2, 3, 4, 5, 6, 7. Oh no, what am I going to do? I don't have enough space. Let's get creative here. Let's make them go by 2s. So it's going to be -2, -4, -6, -8. There we go. Okay, so I'm going to start at -8. Okay, this is 2, this is 4, this is 6, this is 8. So I'm gonna go 1 to the right, change in the height. How do I go 1 to the right? Ooh, I don't know, just guess a little bit. If a whole thing is 2, half of it would be 1. So 1 to the right, change in the height means I'm gonna go up 4, over 1, up 4, over 1, up 4. I'm actually glad I did this because if you notice carefully, okay, over 1, up 4 by my adjusted scale, or my adjusted graph, is still the same thing as over 1, up 4 for the regular squares. If I go 1 square this way and 4 squares up, it's almost like I skipped that corner point right there. Okay, it's the same move. Over 1, up 4, over 1, up 4 is the same thing as over 2, up 8. So 1 to the right, change in the height, does not fail me. Okay, so let's play connect the dots. You only need 2. I like to make a couple just because I like to be accurate. Okay. Plus, it'll also kind of help with my halfway points. As you can see, my halfway point was kind of lame right there. Not very good. All right, got it. There you go. So again, y-intercept is where you start. Slope is how you move, or the slope is how you step. End of story. Goodbye.